Okay, so now that we've spent a couple days on definition of derivative, we're going to look at some derivative techniques using mostly something called the power rule of limits. So they say if n is an integer, then d dx of x to the nth power is n x to the n minus 1. So the way the power rule works is the n comes in front, it gets multiplied by whatever's there, and then you subtract 1 from the exponent. They're talking about the fact that if c is a real number, so going back here, then the derivative of c is 0. And that's because even if we use like the power rule, like let's say I had just a constant, right? A real number, 2. Well, 2 could be written as 2x to the 0 power, right? Because x to the 0 power is 1, 2 times 1 is 2. So if I used power rule, I would do 2, so if I started with this as like, I don't know, being some y function, then dy dx would be, I would say 2 times 0, which is 0, x to the, I would subtract 1. It'd be to the negative 1, which 0 times anything is 0. So the derivative of a constant is 0. Here it says, in science, the first derivative is known as the velocity, and the second derivative is known as the acceleration. Okay, so here, f prime of x. The 9 gets multiplied by the 1. 1 times 9 is 9. X to the, we subtract 1 and get 1/8. So that is the first derivative. First derivative here, 1 times 1 is 1. X to the, we minus 1 would be x to the 0. But x to the 0 is 1, so that's really just 1. So I wouldn't normally go through all of that. I would just say f prime of x is 1. F prime of x here, well, this is a constant, right? This is a constant. It's some number. So when we take the derivative of a number, we get 0. First derivative here, we multiply 2 times 3 is 6, x to the subtract 1, so it's x squared, minus 2x to the first, right? Because if you subtract 1 there, it's going to be an x to the first. Derivative of 1 is 0, so we don't need to write plus 0, so that's my derivative. This next one, I'm going to rewrite it first because I see a square root in there. So 2x to the negative 3, 9x squared. Since this is power rule we're using, we want this written as a power. So square root of x is x to the 1/2 power, right? If it was cubic root, it's to the 1/3. Fourth root is to the 1/4. So when I do f prime of x equals negative 6x to the negative 4th, right? I'm multiplying these and then subtracting 1 off of negative 3. Negative 3 minus 1 is negative 4, plus 18x to the first minus half of 6 is 3. X to the, well, if I think of subtracting 1, 1/2 minus 1 is the same as 1/2 minus 2/2, or negative 1/2. So this would be negative 1/2. And then the derivative of 4 is 0. So that's our first derivative. Now, what you'll probably see, because a lot of times with derivatives, we have to plug in an x value. So this x to the negative 4, I would want to bring down and know it's x to the positive 4. X to the negative 1/2, I would bring down and it would become x to the positive 1/2, which is the same as square root of x. Now, sometimes people get bothered by that because they say, wait a minute, I thought you don't leave a square root in the denominator. When we're doing derivatives, we can, because what we want to do is we want to plug in usually. Usually we're going to plug in a number. If I want to plug in a number, I want it in this form where it says square root of x, so I can plug in the number. Now, technically, you didn't necessarily have to go that far. Like you could have stopped here. But for things we do in the future, or let's say it was a multiple choice, you might have to know that these are equivalent. Okay, so for right now, for letter F, you are going to have to write this out twice in FOIL. So f of x is 4x squared plus 4x plus 1, which means f prime of x, 4 times 2, 8x to the first power, because again, we're subtracting 1 off of the 2. Derivative of 4x is 4. And again, that's because like if you thought 4x to the first, you'd multiply. 1 times 4 is 4. X to the, we'd minus 1, so that'd be 0. But then 4 times 1 is 4. So it ends up just being the coefficient there. And the derivative of 1 is 0. So we're done there. Next one, they want to find the derivative, but at x equals 1. So first I have to rewrite f of x. This is not in a form where I can write the derivative. I need it written as x to the negative 2 plus 3x to the negative 3. I have to almost do the reverse of what I normally do. I have to flip it up and actually make it a negative exponent so that I can use power rule. So this is negative 2x to the negative 3. This is negative 9x to the negative 4. So now I did the derivative. Now I'm going to write this how I normally would with positive exponents. I'm going to evaluate this when x equals 1. So it's negative 2 over 1 cubed minus 9 over 1 to the 4th. Negative 2 minus 9, which is negative 11. So that could either be like, what's the instantaneous velocity at 1 second? We could say negative 11. A velocity can be negative because it indicates direction. Or it could be saying, what is the slope of the tangent line drawn to that curve at x equal 1? It would be negative 11, so on. Okay, so for dy dx, or I could use y prime, I first need to rewrite y as 1/2 x to the 4th plus 7/2. Right? I have to first have terms. I can't have a factor because we don't, later on we'll learn something called power or product rule where we could deal with a product. But right now we're going to have to distribute that. 1/2 times 4 is 2x to the 3rd because again we take 1 off the exponent. The derivative of 7/2 is 0. So again, we don't have to write plus 0. I'm going to skip around a little bit. because I is similar to one we've done. So is J. For K, you would just rewrite Y is x squared over 5 plus 1 over 5. And that even could be written as a 1/5 x squared plus 1/5, right? Because this is a 1 up here. So now if you did dy dx, or we could call it y prime, 2 times a fifth is 2/5, x to the first, plus 0. Okay, looking at just to write it a little bit, well, yeah, first we're going to rewrite y. So we have x to the 3/2 over x minus 2 over x. Remember, we subtract when I have x to the 3/2 over x. I would do 3/2 minus 1, which is 3/2 minus 2/2, or 1/2. So this is x to the 1/2 minus 2x to the negative 1. So again, that's an x to the 1 on the bottom. I want to flip it up, becomes x to the negative 1. Now I'm going to take the derivative. So I'm going to call this y prime. I could say dy dx, but I'm just using a different notation. I'm going to say y prime just to practice that. So this is 1/2 x to the negative 1/2, right? If you do a half minus 1, it's negative a half. Negative 2 times negative 1 is a positive 2, x to the negative 2. So this would, oh, yeah, and I didn't even notice here. This says find y prime of 1, so that's also a reason to use y prime. So we're flipping our negative exponents down. Then it makes sense here to write that as square root, because it's to the 1/2 power, and y prime of 1 then is 1 over 2 square root of 1 plus 2 over 1 squared. That's a half plus 2, which is 2.5, is y prime of 1. Oh. Oh, I'm just noticing in the original problem, for some reason, I made that minus. That's plus, so then this is minus all the way down. All right, so sorry, this is a half minus 2, which is negative 1.5. Okay, and then the last one is going to look at the second derivative. d2y over dx2 means second derivative. So y, first of all, we're going to do 3x over 5x minus 2 over 5x. Simplifying, that's 3/5 minus 2/5 x to the negative 1, right? We flip the x to the first on the bottom up, it becomes an x to the negative 1. So when I'm doing dy dx, which is the first derivative of 3/5 is 0. Product rule, that'd be 2/5 x to the negative 2. Which means when I do the second derivative, d2y over dx2 squared, looks like. When I do that, it's going to be, we're going to multiply, so I'm going to get negative 4/5. Negative 4/5 x to the negative third. And then I could write that negative 4 over 5x cubed is my d squared y over dx squared. The last thing here is pretty easy. It's just saying the derivative of e to the x is e to the x. It's its own derivative. So if I were taking the derivative here, f prime of x, the derivative of e to the x is e to the x. So this would be 4e to the x minus 3 times 2 would be 6, x to the first power. So I would use power rule with the second. I would not use power rule with the first because it's an e to the x. Huh. Just seeing, this seems long here. Okay. Okay, it says write the equation of the tangent line to the graph at the point. Okay, so f prime of x equals derivative of 2x is 2. This is minus 1/2 e to the x, which the derivative of e to the x is e to the x. Evaluate that at 0. E to the 0 is 1. So this is 2 minus 1/2, which is 3/2, or 1 1/2. So writing the line, we would go y minus the y equals m parenthesis x minus the x, which we could leave like that, or we could say it's that, or we could even, if we wanted to move the 1/2 over, say it's that. But any of those are fine. What points on the graph of f where the tangent line is, or find the points where the tangent line is horizontal? If the tangent line is horizontal, remember the derivative is the slope of the tangent line. So the derivative would have to be 0. Because if the tangent line's horizontal, we know the slope of a tangent line is 0. So this is a different way of saying from up here where we had f prime of x equals 2 minus 1/2 e to the x. Here, the slope, the first derivative is 0. And then we solve. Divide by negative 1/2 or multiply by negative 2. We're going to get 4 equals e to the x. Just a reminder from earlier, we would take the ln of both sides. So ln e to the x equals ln 4. Use the power rule to bring the x in front. Ln e is 1, so x is ln 4. To get the y coordinate, we're going to do f of ln of 4. So that's going back to the original f of x function. So it's 2 times ln 4 minus e to the ln 4 over 2. So here we reverse the power rule. It's ln of 4 to the second minus e to the ln 4 is 4. So this is ln 16 minus 2. So ln of 16 and then minus 2. So the point is the x, ln 4, comma, ln of 16 minus 2. That's our point. Okay, so it says For what values of x does the line tangent to the graph of f have a slope of 6? Slope of 6 means f prime of x is 6. So when we do f prime of x, we use the power rule, 6x squared minus 24x plus 24. Set that equal to 6. Solve. Divide by 6. I usually do that when there's a GCF just to make the numbers smaller. Factor. X is 3, x is 1. And that's all they asked for is the x value. So sometimes they'll ask for the point, sometimes they'll just ask for the x value. They're just talking about how second derivative is written, first derivative is written. Okay, so they're saying to find the third derivative. If they give me f of x, I'm going to say, okay, f prime of x, which is the first derivative, 9x squared minus 5. Then f double prime of x, which is second derivative, is the derivative of the first derivative. And then f triple prime of x is 18. Now, if it's y, I can use y prime or dy dx. So let's say I say y prime is 3 plus 2e to the x. Second derivative, the derivative of 3 is 0. Derivative of 2e to the x is 2e to the x. Third derivative, the derivative of 2e to the x is 2e to the x. All right, last one. So it says find the body's velocity and acceleration. Okay, so the velocity, the v of t, is the same as s prime of t. It's the first derivative. So that would be 160 minus 32t. And that's the label would be meters per second. Oh, sorry, it's feet per second. And the acceleration is the second derivative. So a of t is going to be v prime of t. It's going to be the derivative of the velocity, which is the derivative of 160 is 0. The derivative of negative 32t is negative 32. And that would be in feet per second squared. The second is squared. So velocity is first derivative. Acceleration is second derivative. All right, that's it for the day 3.